Okay, last example for Chapter 8. 2 pain relief drugs are being considered. A random sample of 8 doses of the first drug showed that the average amount of time required before the drug was absorbed into the bloodstream was x bar 1 equals 24 minutes, with standard deviation S1 equals 3 minutes. For the second drug, a random sample of 10 doses showed the average time required for absorption was x bar 2 equals 29 minutes, with standard deviation S2 equals 4.9 minutes. Assume that the absorption times follow a normal distribution. Find a 90% confidence interval for the difference in average absorption times for the 2 drugs. Well, the first thing I notice is we are giving S's, the sample standard deviation. And as soon as I see I'm given S's, I know that I'm going to be using the t distribution. Okay? So anytime we use t distribution, we know we need degrees of freedom. Now we have 2 sample sizes, right? We have N1, which is 8, and we have N2, that's 10. We always use the smaller sample size. So our degrees of freedom this time are going to be 8 minus 1, which is 7. Okay. Now, following our 3 steps we always do, first we're going to find this error. We're going to use our t critical and then multiply that by the square root of S1 squared over N1 plus S2 squared over N2. So for t critical, I'm going to use my t table. I'm going to go down to 7 degrees of freedom, and we want a 90% confidence interval, so 0.900 down to 7 degrees of freedom, and I'm at 1.895. Okay. So t critical is 1.895 times the square root of, okay, S1, which is 3, so 3 squared over N1, which is 8, plus S2 squared, so 4.9 squared over N2, so over 10. Okay, and we work this out. So again, all I'm going to do is take my 1.895 times the square root of, and then 3 squared divided by 8 plus 4.9 squared divided by 10, and I get 3.558, so 3.56. Okay, so that's our error. Now we also need that x bar 1 minus x bar 2. So look it up in the problem. X bar 1 is 24. X bar 2 is 29. So we get a negative 5. Okay. Now, my confidence interval is the x bar 1 minus x bar 2 minus my e is less than mu1 minus mu2 is less than, and then this x bar 1 minus x bar 2, so negative 5, plus e. Okay. So when we work this out, we get negative 8.56 is less than mu1 minus mu2, which is less than negative 1.44. Now again, we don't really care about the numbers. All we care about is the fact that both of these are negative. Okay? Since they're negative, remember the answer to the subtraction problem is negative. That means the second value is larger. So we are now saying that mu1 is smaller than mu2. Okay? Or mu2 is bigger than mu1. Right? So when we go to our conclusion, I'm going to say, I am 90% confident that the population mean, now the population mean what? We're talking about the time it takes to be absorbed, so the absorption time, so that the population mean absorption time for the first drug is shorter than for the second drug. Okay. Or the second drug takes longer to absorb into the bloodstream than the first drug. Okay? All right. Let me know if you have any questions.